I'm here to talk about how to build, train, and analyze machine learning models in a new, fast way. I'm here with my co-founder, Robert, who will show you a live demo of our solution or of what we have built so far. To start with, how many of you have ever worked with machine learning models before? Please raise your hands. All right, that's some of you. So when you're working with machine learning models, you most likely use an interface. And there are different kinds of interfaces, like static ones, dynamic ones, high level and low level. But there aren't really any graphical interface. And I find this interesting. I find it interesting because a machine learning model is perfect to be represented as a graph. And this can be intuitively done with the drag and drop interface, where each node corresponds to an operation and each edge corresponds to the data flow. And there are some machine learning frameworks out there which lets you build and train machine learning models easier, like TensorFlow, Keras, and PyTorch. And me personally have most experience with TensorFlow. So the machine learning frameworks has changed a lot over the last 4 years. The evolution has been really impressive. And many iterations have created different trends. And in my opinion, this really highlights the importance of frameworks interface. So Keras, for example, it's very high level, but it's becoming more and more flexible. And then we have TensorFlow, who is great for serving model in production, but has been lacking Pythonic programming and eager mode. While we have PyTorch, who has the Pythonic programming and eager mode, but lacking in serving models in production, until recently. So TensorFlow 2 comes out, and it now has Pythonic programming and eager mode, and PyTorch now supports serving model in production. So in some way, it feels like it's becoming the same framework. But I really think that we can see that developer wants the transparency and flexibility of a low-level API while working with the high-level API. And TensorFlow 2, Keras, and PyTorch are really making steps to solve this. But when they're wrapping the low-level API, they make it tedious to write the boilerplate code for visualizations. We're introducing a flexible platform where the developers get transparency in developing models, and we enable for fast model iteration. And just as what TensorFlow are trying to achieve, we want to bridge the gap between the beginners and the researchers. So how did we come up with the idea of PerceptiLabs? Me and Robert, at the end of 2016, me and Robert participated in a hackathon in Europe, where one of the competitions or challenges was to use European Space Agency's satellite data to build something good for the environment, or more specifically, to save the Arctic. So we decided to build a CNN, or a fully convolutional neural network, such as UNet, to track fish swarms. And the competition went on for 3 days. And after a full day of work, we realized that we will not be able to build this model and train it. And bear with me that this was 2016, so it was even trickier back then. And this was when the idea of PerceptiLabs was born. We saw the potential in building an interface of something that can cut down on model development time and also increase the transparency while training. So what happened with the hackathon? We spent 16 hours building a VR game in Unity instead, where you fight burning coal and pollution to save the Arctic. Fun fact is that we actually trained a model or an agent to play this game with reinforcement learning in our platform. And that's when we decided to integrate Unity as a plugin. So, building a model is a long process. And after building several models, we realized that we have to write boilerplate code for visualizations and to debug models. And after this hackathon, we started building PerceptiLabs, a platform where you can easily build out models, iterate through different model architectures, get instant feedback, and in an intuitive and easy way, debug your models. So we have built this platform now for 2.5 years. And finally, last week, we released the open beta version. We have had alpha testers and beta testers from Stanford, Berkeley, Google, ABB, Red Hat, and more. And this is something that we greatly appreciate. And with all this user feedback and the iterations, we now have sort of a machine learning IDE, where we have all the boilerplate code for visualization built in, and you can run on your own local environment, and we support all the machine learning techniques, such as supervised, unsupervised, and reinforcement learning. So let me walk you through the 3 different key values that the platform provides. So with the drag and drop interface, you can quickly build out the model architectures. You can prototype and iterate through different solutions. And in each layer component, you have settings or code. It's the user's choice. And if you apply the settings, you will get an instant feedback by getting the output visualized. And if you get an error, you can see right away what error you get and where it is in the code. And instead of you having to manually calculate all the input and output dimensions of each operation, it's done automatically, which of course speeds up the process. So all the boilerplate code that you have to write for visualizations, built in and taken care of. So you can create your own statistic dashboard in real time and choose what you want to visualize. The drag and drop GUI, it is probably the most high level you can get. But in each component, we have the low-level code, so you get transparency and really understand what it's running. And also with a GUI, you can, for example, you see the model architecture very quickly. So you can, for example, take a look at the illustrations in a machine learning paper, copy it into the GUI, and run it right away. It's a very fast way of training models. And for now, we have the low-level code written in TensorFlow 1.x. And the parser that we have to import pre-trained models is built for TensorFlow models. But we are aiming on getting the parser generic, as well as getting templates for TensorFlow 2, Keras and PyTorch as well. But anyway, we'll let you run in your local environment. So as I said before, you can see it as an IDE. We provide with plugins such as Gym and Unity, so you can easily train and run reinforcement learning. And the workspace is purely data flow driven, so you can almost create anything. You just have to connect the correct output with the correct input when you're defining the data flow. I'm going to introduce or invite Robert here now so he can give you the live demo.
Thank you, Martin. So, the first thing we see when we open the platform is a project screen, where we can we have some basic templates which you can select from. In this case, some image classification, time regression, reinforcement learning. We have a get started guide, which takes you through the platform and also teaches you a bit about how AI actually works. And finally, we have where you can load saved projects or create new ones. So let's go ahead and create a new project. And I'm going to build a simple MNIST model, similar to the one you saw in the GIFs earlier. So the first thing we do is that we take a data component, which will define your data source. And this, so we load in the data source, and we press apply, and we instantly see the visual feedback of what the output is. This one looks a little bit weird, but that's because the image is flattened. We will reshape it in the next component. So we combined these different components using this arrow, basically defining the data flow. And everything from the previous component will be available in the new component as you do so. As you can see here, it has been reshaped, and you get the instant visual feedback of it. For the rest of the model, I'm going to build a simple convnet. So we will have a convolutional layer and a fully connected layer. And as we go through it, we can also see how you have all of these settings where you can predefine how you want the component to look like. But if you want to do something a little bit creative or mix some things up, you can always go into code, and you get the full code editor there. So everything which is ran inside of this platform, you get full access to. And we also provide some debugging tools, so say that you write something wrong, you easily get an error message as well as showing what's actually going wrong. And here we can also see that we have a drop-down for each of these, where you not only can see the direct output, but you can also go through the different variables inside of the component and take a look at them to make sure that everything looks good. So we want to do as much as possible to make sure that you can debug your model as well as the code. So now that the trainable part of the model is done, we will add some labels to it. To do that, we add a second data source, which will be the labels, and these are just like MNIST is the handwritten digits from 0 to 9, this will be the digits of 0 to 9. And to make sure that it matches up with the output of the network, we make sure to one-hot it, which just transforms it into an array of 10. You can see exactly how the process works. And then we have both parts which we need for our network to start training. Now the last component we're going to put in is something which we call a training component. This is what combines the entire network and makes sure that the model trains as it should. It's also here where you can set things such as loss and accuracy or optimizer. We have a few different training components. So we have train normal, which is normal supervised learning. But we also have train reinforcement and train gun. And as you've seen, these are all just templates for code. So you can create your own or change them as you wish. So we connect the two components to this training component, and all we need to make sure is that the labels are the correct one. Everything else is set up to work for this one. Okay, now we have an entire network, and we can now start training it. When we want to train it, we have the option to run it either on the local computer, or we can swap over to cloud and run it at the moment on Azure, where we help you set everything up, and just by the click of a button, you can start running it in our cloud. As soon as we start training, we will get thrown into a statistic dashboard. And I'm going to go through what these different are. At the very top, you see 4 squares. This shows you the overall performance of the network. So you can see how we see the input over here. We have the current accuracy. We also have the prediction versus ground truth, both for a single sample and for a batch. At the bottom right, you see something which we call the view box. This allows you to peek into every component of the network to see how they're performing in real time. You select which component you want to press into by just clicking on the map. And this way you can go through the bias or the gradients, everything you need to see to make sure that it's training. We also show the accuracy and the loss, all the standard you would want to see. Okay, so just finished training, and as soon as it's done training, we can go into the test, where you can go through your test samples one by one, and just like in the previous view, click through the different components. And this way you can make sure that everything looks as it should on the test data as well. When you're done with everything, you can go over to export, and you can export the model, as in this case a TensorFlow model, and you can have a different, you can use it as compressed or just a normal one. And that is a model built. So I would now like to invite Martin back up to the stage.
So you can just download it and try it out if you want to at this link. It's free desktop app across platform. And also we're going to have here in San Francisco have work sessions and hands-on sessions such as Lunch and Learn. So if you're interested in participating, feel free to reach out or come say hi at our booth. Otherwise, thank you very much for listening.